Once upon a time, in a world not too long ago, there lived a scientist named Joseph Farman. He was a curious and diligent man who spent his days studying the Earth's atmosphere. Joseph had always been intrigued by the mysteries hidden within the layers of air that enveloped the planet. In the brisk October of 1982, Joseph Farman was meticulously measuring the ozone content in Earth's atmosphere using advanced machinery. To his astonishment, the device displayed a perplexing reading, suggesting a staggering 40% decline in ozone levels compared to the norm. Bewildered by the numbers, Farman's skepticism led him to question the reliability of his equipment Dobson spectrophotometer. He with his team refined their instruments, double-checked their calculations, and engaged in intense debates to ensure the accuracy of their conclusions. The puzzle pieces were falling into place, and a breakthrough was on the horizon. Year after year, Farman persisted in his research, armed with progressively refined equipment. Yet, with each return, his measurements unveiled a disconcerting trend: ozone levels continued to plummet. Hesitant but determined, he decided to share his findings with the esteemed NASA scientists. This collaborative effort resulted in an alarming revelation: an ozone hole had emerged over Antarctica, and its expansion was accelerating annually, sparking a global environmental emergency. This was a region in the Antarctica stratosphere where the ozone layer was significantly depleted, allowing higher levels of harmful UV radiation to reach the Earth's surface. Let's delve into a fascinating narrative that unfolded decades ago, a story that encompasses scientific breakthroughs, global collaboration, and the power of collective action. Step into the early 1980s, where scientist Joseph Farman found himself amidst the snowstorms of Antarctica, unknowingly stumbling upon a revelation that would reshape the world as we know it: the ozone hole. But before we proceed, let's take a brief look at the intricacies of the ozone layer. This protective region hovers between 15 and 35 kilometers above the Earth's surface, primarily comprising ozone molecules. This delicate layer plays a critical role by shielding life on our planet from the sun's harmful ultraviolet radiation. Ozone also plays an important role in regulating the Earth's climate. While ozone itself is a greenhouse gas that can contribute to warming, its presence in the stratosphere is essential for maintaining the temperature balance of the planet. Changes in ozone levels can influence atmospheric circulation patterns and weather. The root cause of this ominous ozone hole was eventually traced back to chlorofluorocarbons, compounds found in common products such as aerosol sprays and refrigerants. CFCs, once released into the atmosphere, triggered a chain reaction that introduced chlorine into the ozone layer. This disruption initiated a self-propagating cycle of ozone molecule destruction, leading to a gradual depletion. Chlorine, often released from human-made chemicals like CFCs, reacts with ozone molecules in the stratosphere. When a chlorine atom colloids with ozone molecule, it breaks ozone molecule into oxygen molecule and a nascent oxygen. This interaction triggers a series of chemical reactions known as catalytic cycles, creating more oxygen molecules in atmosphere than ozone molecules. In these cycles, a single chlorine atom can destroy multiple ozone molecules, causing the ozone layer to thin out. This phenomenon is particularly prominent over polar regions, leading to the formation of the ozone hole. The pivotal moment arrived in 1987 when the world rallied together under the Montreal Protocol, an international treaty signed by all 198 United Nations member countries. This unprecedented accord aimed to phase out the production and consumption of CFCs and other ozone-depleting substances. It stands as a remarkable testament to global cooperation in the face of an impending ecological crisis. The Montreal Protocol has had a significant impact on reducing the production and consumption of chlorofluorocarbons and other ozone-depleting substances all over the world. By 2010, global CFC production had been virtually phased out, and consumption was significantly reduced. Thanks to the swift response of nations, CFC consumption dwindled over the years. While the ozone hole persisted and even expanded during the 1990s due to delayed effects, the situation eventually took a positive turn. At present, the ozone hole is gradually receding, with experts projecting complete recovery by 2066 over Antarctica and 2045 over the Arctic. The saga of ozone layer depletion and recovery serves as a poignant reminder of our capacity for collective action. As we look back on this extraordinary journey, we're prompted to consider the implications for our present challenges, particularly the pressing issue of climate change. This marked the beginning of a concerted effort to mitigate the crisis. Governments, industries, and scientists united to develop and implement alternatives to CFCs, such as hydrochlorofluorocarbons and hydrofluorocarbons, which have significantly lower ozone-depleting potential. The unity and coordinated efforts that mitigated the ozone crisis stand as a beacon of hope for addressing contemporary global environmental concerns. As we conclude this captivating narrative, let us reflect on the lessons it imparts. The tale of the ozone layer's odyssey offers us not only inspiration but also a blueprint for tackling the world's most daunting problems. Your engagement is paramount, so if you found this discourse enlightening, remember to like, subscribe, and share. Stay curious, stay committed, and together, let's usher in a more sustainable future for our planet. Thank you for joining me, and until next time, keep exploring and advocating for positive change.